So, chapter 10, if you remember, it dealt with, well, it introduced different types of waves and basic properties of them. We talked most of the chapter, the second part of the chapter talked about the most common waves that we see, which are the wind waves. This chapter, chapter 11, kind of adds on to that and talks about mostly the other types of waves, the shallow water waves that have a longer wavelength, so they're kind of big waves, so seiches and tsunamis and the tides, which have the longest wavelength of all. So, while I'm waiting for my husband to finish his surgery, I thought I'd try and do a little video lesson for you to do with this chapter, at least the first part, and then I'll probably try the second part. But unfortunately, there's no access to internet, so as I go through the slides, just remember you can pause it at any time, so you can watch the video lesson, pause it, and then have the slideshow open from Edmodo or the class notes page, and then click on the live links that'll show you videos and animations to help you understand them. Okay, so anytime it says video or animation, you should be able to click on those words in the PDF file, and they'll open the other links for you. Otherwise, you can always find them right on the class website too. Okay, so we'll start off by talking about storm surges, and you've already seen these in earlier chapters, but just so that you understand how they compare to actual waves. So, storm surges are basically a bulge of water, usually generated by a tropical cyclone. So that's if you remember the cyclones, they are wind storms that have a wind speed between 63 and 117 kilometers an hour. So again, if that's happening above the water, the energy is transferred into the water, and then the water can move in a bulge, like a storm surge. And storm surges, this graphic is pretty good. There's my cursor. Okay, so it shows the average tide level here in the dashed line. So normally high tide would go up probably a bit and then down for low tide, but a storm surge causes an additional large amount of water traveling above that. So it actually can move water right in onto land, depending on what the shape of the boundaries are. They can be more or less destructive. So basically they can add up to 7.5 meters to the coastal sea level, or even more if it's a certain kind of boundary, like a bay or an estuary. There's some different factors that contribute to how severe the storm surge can be. For instance, how strong is the storm? Obviously, the stronger it is, the greater the storm surge that can be developed. Whether it's high or low tide. If it's high tide, then it's already high, like the water's already high, so the storm surge on top of that is going to be even more damaging. If it's low tide, then it's not going to add as much, but it still can be damaging, not quite as high. The layout of the shoreline, again, if it's more gradual, if there's no real major slope or major increase in the land as it's coming in, then the water's not going to slow down as much and it can go in further. The storm surge are not considered true waves, only the crest of a wave. So it's not a true wave, it's not a tidal wave, although sometimes people will call them a tidal wave. They're really not waves. Since there's no trough, no period can be assigned to them, so they're not what we would consider a true wave. There's a couple of videos there. If you click on them, so you can pause this video and then click on those links in the live PDF file, then they should open for you. Otherwise, you can find the links to them right on the website. I'll put them in Edmodo too. There's lots of them that you can watch. Okay, so that's it for the storm surge here. Second type we're going to talk about are the seiches. So one is a seiche. We'll talk about more than seiches. The easiest way you can think of a seiche is kind of like what happens in the bathtub. If you start moving towards one end of the bathtub, then you generate a wave that goes and hits the back wall of the bathtub, and then it'll go backwards behind you, and the more you cause that to happen, the higher the wave can get. So that is safe, and that can happen in harbors and areas like that as well. Okay, so it's basically disturbed water in a confined space. Hi. Oh, they just came to give me an update. So, let's see, where were we? So, again, a seiche is disturbed water in a confined space. Basically, the water sloshes back and forth at a specific frequency, and it kind of can resonate or add upon itself. If it keeps going back and forth, it can get higher. They were first studied in Lake Geneva because they noticed that when breezes pushed the water to one side of the lake, and when the breeze stopped, it would move back to the other. So oftentimes they're called a standing wave because they oscillate, or in other words, they go up and down vertically. There's no real forward movement of the waves. The water rises on one end and then falls, and rises on the other end and then falls. Okay. And just like you can do in a bathtub, you can add energy rhythmically. So when you push in the bathtub, you can make the waves go up higher. Is basically what it's the same thing. The node is that point in the center where there's no real movement, no rising or falling of the water. Okay, but if you were to watch, for instance, you watch this boat on the left, as the water moves to the one side of the harbor, it'll rise, and goes to the other side and fall. And there's another animation that happened in the pool during, not even during the earthquake, can't remember. I remember watching it and think it was pretty neat. So I shared those two, so you can click on them and have a look at some real seiches. No idea how to picture it. Tsunamis and seismic sea waves, so they often call tsunami seismic sea wave or vice versa. We talked about them earlier when we talked about earthquakes that happen out in the water. So start with what the word means. So tsu is harbor, nami means wave, so basically a harbor wave, because they make their way quickly towards shore and can cause a lot of damage. So if you remember back when we were learning about how the plates move, we have when one ocean plate is basically subducting under the other, when they're coming together and one goes under the other, there can be a major stress point that could form, and eventually that can let go, and then there's an upward thrust. There's an upward thrust right where that happens, and that generates a big wave. So that point where that region where the upward thrust happens, that's called the epicenter. So that would be the epicenter, and then the waves will start to progress outward from there. In the last chapter, we talked about other properties like its wavelength. It has a really long wavelength, up to 200 kilometers. So it is obviously a shallow water wave because it can never get deeper than half its wavelength. Half its wavelength would be 100 kilometers. So the deepest point in the ocean, the deepest trench, is only 11 kilometers. So it will never be a deep water wave, always shallow water wave, and so it's always feeling the pull of the ocean floor. It's progressive, meaning it's not just staying still, it's moving. You can see the waves moving forward. Speed, really, really fast, 212 meters per second. Okay, so when it happens, it doesn't take long for it to reach the shores. So there's not a lot of warning. I remember watching the video about the one in Japan a few years ago. they really didn't have time to do much to prepare. Again, it's affected by the extent of damage or the extent of which it can go up on the shore. It depends on what the shoreline is like. The crest is obviously going to grow as it reaches the shore, and the water at the bottom slows down and it moves very quickly onto shore. So there's a couple of videos there you can probably think back to the one that we watched about the one in Japan and the one off of land. So this is just again saying what I just said with the other graphic, but a couple other graphics showing the same thing. Here's the earthquake. There's a vertical displacement, so in other words, the one plate kind of very quickly bounces backwards towards the surface, and so that causes a major upthrust of water or vertical displacement of water, and then the gravity tries to pull it back down, and that generates the waves that move outward from the epicenter. So here's the upward thrust. This would be where the epicenter is here, and then the waves move out all around from that epicenter and they head towards land. I think that's it for the first part. Oh, encountering, what's it like? Okay, so if this is where the epicenter is, and it sends out a wave, and you were a ship out on the ocean, you really probably wouldn't even notice that a tsunami is moving, because the rise and the fall happens over a fairly long time, so they wouldn't really notice. You wouldn't see a big wave coming at them. Only when they reach the shore, they notice. So when it reaches shore, the water at the bottom slows down, the wave height is going to increase immensely, and then the water is going to surge onto land at a very high, fast tide. So really, really scary if you ever had to encounter one on shore. But if you were on a boat at sea, you probably wouldn't even notice that it was passing by you, under you. Okay, I think I'll stop here and then do a separate video on the tides. It's actually a longer part of this chapter because it's about how you read the charts and everything. So I'll stop here for now.